Number 25. So this is the last problem of the AMC 12, and the last problem tends to be the most difficult. However, I'll try to explain this as easy as possible. For every integer n is greater than or equal to 2, let power n be the largest power of the largest prime that divides n. For example, power 144 is equal to 9, because as you see, the 3 to the second overrides the 2 to the fourth. What's the largest integer m such that 2000 to the m's divides this? So 2010 has to 2000 to the m's power must be in the denominator, and this huge product has to be in the numerator. So I can write down as pi. And the result has to be an integer. Okay, let's take a look at 2010 and see if we get the prime out of this. You can divide it by 2 because it's an even number, and you get 1005. Now the sum of the digits becomes 6, and if you divide by 3, 6 is a multiple of 3, so therefore you can divide it by 3, so you get 3 and 3 and 5. Okay, you can further divide it by 5, 7, oops, that should be 67. Therefore, I can write 2010 as 2 times 3 times 5 times 67. I can replace this number into 2010 in the denominator. Therefore, I can write as 2 with a parenthesis 2 times 3 times 5 times 67, or in the parenthesis to the m. However, I can also distribute that. So I can rewrite it as 2 to the m times 3 to the m times 5 to the m and 67 to the m. And then on the top, I can take a look, or I can expand this out as power 2, power 3, power 4, and then multiply by lots of number until you hit power 5300, and they're all multiplied because that's what the pi capital notation is about. Okay, so this value becomes 2 and that value becomes 3. Here's something you have to be careful. When you have 2 to the second, it's not only 2 get taken out to be the value of this function, it actually takes the exponent as well. Something to be careful. Alright, because we want to get ultimately an integer, we really have to be concerned with something that matches our denominator's power here. So our interest on the top is really 2 to the a power, where a is something we don't know yet, and 3 to the b, and 5 to the c, and 67 to the d. Now of course there will be more numbers such as 7, 13, 11, 19, but for all those other prime numbers, I'm gonna just all trash them or collect them into Q, because they will be integer anyway when they are multiplied, right? So this is our concern, and you have to take a look at closely look at this. Alright, when you see that we want to have the largest m, but we still want the integer here. To satisfy the condition, we're really looking for the smallest out of these 4 exponents, a, b, c, d. Because once you have the greater one, say for now the c is 30, right? And then we have 30, a is 31, Okay, let's make it a equals 31, b equals 32, c equals 33, and d equals 34. Then as long as n is 31, then the greater exponents such as b and c and d will be just integer multiplication. So we have to find the largest integer m, and that translates to the smallest integer of among the a, b, and c and d. So I can write our goal as we're looking for m, the largest m possible, and to create an integer you must have a minimum of a, b, and c and d, one of these. Okay. Now if you are the AMC student and you solve a lot of difficult problems, you should have some intuition here that 67 should be the candidate. The reason is 67 here will be the least common out of all others. We already have 2 to the first and then we have 2 to the second here, right? So obviously there will be lots of 2s. Technically there will be more 3s and 5 because 3 and 5 has this that can be multiplied by 2 and they override 2. So that technically 2 and 3 and 5, you can kind of see that there will be a lot of them because they're like the stepping stone of the prime factorization. But when you get to 67, there are not that many. So let's tackle that. So let's see how many 67 multiples of 67 we get for the n. So we have 5,300 numbers. Okay. In other words, you see up there 5,300 above the notation. When I divide it by 67, okay, you're gonna notice that we can have as many as 79 numbers. Okay. So in other words, 5,300 is equal to 67 times 79 plus 7. We can disregard 7 and we just cannot go over 5,100. So this is n value, by the way. $79 possible numbers. And when you have those multiples of 67, you're gonna get 67 out of it in the pow function. So for example, when I say pow 67, well, obviously it's going to take out the 67. Over here inside the parentheses, that's what equals n. When you have pow 2 times 67, so that should be like 134, right? Okay, so in other words, if I have a number such as 134 here, guess what? It's still going to be 67 because 67 is a larger prime number. Okay. So at this rate, when you have 3 times 67, power of 4 times 67 and on, you're gonna get 67 throughout except the 4 cases. Let's say you go up to 79 times 67. When you multiply these out, okay, let's actually use virtual calculator instead of physical. 67 times 79, you get 5,293. 5,293. Now, as long as this is less than 5,300, then you're okay. So we have total of 79 numbers. That gives us 67. And all those 67 to the first power, well, technically there should be a first power, are multiplied in the capital notation. In other words, if we go back to our form here, so when number becomes like 67, 134, and any multiple of 67, and as long as they are below 5293, you get to multiply all those numbers. So we have 67 to the first times 67 to the first. So in the giant product, I'll write it down. So it becomes like this. You have so many of those. And we are particularly interested in the exponent. And there will be 79 of them. However, there are some exceptions to this. Now you have to be aware that once you go over 67, for example 71, '73 and 79, they are all prime numbers. If they are prime numbers, despite the n is less than 5300, they're gonna take over the 67, and that doesn't help to our 67 to the dth power. So we really have to subtract these three values. So what happened to that? So 79 minus 3, you get 76, right? Okay. But also, we cannot take 67 by itself. So in other words, when you get 67 times 67, sure, you're gonna get 4489. What happened is that instead of we get the 67, we really get 4489 into that giant product, and that's equivalent to the 67 squared. So in other words, I have 76 of these being multiplied, and then also I have 67 to the second power. So adding all the exponents, I'm getting what? 76 of them plus 2 more. Okay, I also have to subtract 67 squared here, by the way, because that's not part of the 61 first. So it should be 75. Yeah. So 75 plus 2, I get 67 to the 77. Also notice, in case you're confused, there's a lot of other numbers being multiplied, but I'm just ignoring all the other prime factors here. Okay, so I'm particularly interested in the 67th power, and it turns out to be 77. Now, if this is a AMC test, so you're not going to have a lot of time, and if you had the intuition that 67 is very least common, and it's also a big number that won't divide as many numbers out of actually from 5300, then you should go with the answer 77 here. However, in this video, I'm also going to show why the answer is 77 by eliminating the A, B, and C here. In other words, they get to be more than the 77, and to illustrate that, I'm going to first start with the A equals 2. Okay, starting with A equals 2, okay, not A equals 2, what was that, 2 to the A. Okay, I'm going to be focusing on the 2 to the A now. The good thing about this number is that this is the least prime number you can have, so there are not that many here. However, this gets pretty close to the number, and he still doesn't beat the 67, and I'll show you why. So 2 to the A, so when n equals 2 to the A, okay. So for example, if n equals 2, 2 to the second, 2 to the third power, 2 to the fourth, 2 to the fifth, and so on. And you'll notice that it's gonna stop at the value where it's less than or nearly as close to the 5300. Well, we actually stop at 2 to the 12th. 2 to the 12th is, you get 4096, but if you go 2 to the 13th, say, you get 8192. That's way over 5300. So we're gonna stop at 2 to the 12 here. Okay. So in other words, when we have something like a 4, when n equals like 8, then we still retain this 2 power of 2. So let's go down here, and they will represent that 2 to the power up there. Okay, so when we multiply all these numbers, notice we are adding the exponent, right? Because when you have the same base, you get to add the exponent. It's algebra 2. Okay, that's the arithmetic sequence in which I goes from 1 to 12 and you have I. The formula is n over number of terms divided by the 2, and the a1 plus a12 in this case, and n was actually 12 here. Therefore, a1 is 1 and a12 is 12. 13 times 2, 13 times 12, you get 156, and divided by 2, you're gonna get 78. Notice that 2 to the 78. In other words, a equals 78. That was pretty darn close to our d here. Okay, I should mention that d equals 77. Okay, now let's go to n equals, not n, when n is, the number n is 3 to b. Now we have two cases. One case is a pure 3 to the b. Okay, this kind of gets more complicated, and later on when you get to the 5 to the c, it gets even more complicated. But what I mean is that when you have 3 to the b, you can either have 2 to the 0, which just become 1, times 3 to the b, or you can also have 2 to the first and 3 to the b, and you can also have 2 to the second times 3 to the b. Why is that? Because when you put this into the power function the problem gave us, these two are smaller prime numbers, so they'll be just ignored. But still, this number represents the n, so we cannot completely ignore the 2's here. So let's take a look. So this becomes 1, so how many b can we have? Okay, in other words, we'll have 3 to the first, 3 to the second, 3 to the third. Okay, obviously these are small numbers, and we have to see at what number we stop. We cannot go over 5300. So 3 to the fourth is 81. 3 to the fifth, it should be 243. 3 to the sixth power, I don't remember all this, so 3 to the sixth, you're gonna get 729. Okay, that's good. 3 to the 7, you get 2187. 3 to the 8th, oh, that's wrong. Okay, obviously 3 to the 8 is too much when you have 6,000 something. Okay, so we have to stop at 3 to the 7th. So what does it mean? In that giant, okay, again, the giant product in the numerator, other than 2's and other prime factors, when we are only concerned with the 3 to the m, 3 to the some number b, we're at least to guarantee that these will be multiplied. So in other words, when we multiply all these numbers, we get to add the exponent. Okay? And that exponent is relevant to our b here. Alright, so moving down here, let's study this case. When you have a 2 to the first power, now I can make our n to be 2650 because now I just divide both sides by the 2. And remember, 3 to the 6 was 729, but 3 to the 7 was 3000 something. No, 3 to the 7. Oh, okay. 3 to the 7 is still possible here. So it's same thing all over again. Okay. So in other words, these will be also multiplied, and we can just add the exponent. What about when you have 2 to the second power? That's 4. Let's divide it by 5300. So 5300 divided by 4, you're gonna get 1325. And obviously you can have all these numbers until where? Definitely not 3 to the 7. I remember it was over 2000. 2187 precisely. It has to be 3 to the 729. Alright, 729 is still under 1325, so we'll have up to 6. Again, when you multiply all these numbers, you get to add the exponent. So all these three cases are just partial, or it's a part of the rest of prime factors of 3. I mean, we can have 3 to the 2 to the third, 2 to the fourth, and sure, the number will decrease, the number that takes the 3 as a base, but let's just count how many we have here. So notice that we can add 1 through 6, so it becomes 1 plus 2 plus 3 plus blah 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 up to 6, and there are 3 of them, so we're gonna multiply by it, and then we have a 7 up there, right? So when you add all these numbers, this will be, by the way, b. When you add them up, so 1 through 6, let's use the arithmetic series. 7, and then there are 6 terms. You divide it by 2, you get 3. 3 times 7, you get 21. So 3 times 21 plus 14, you're gonna get 63 plus 14. Wow, that's already 77. And because I already explained that this is only part of them, we are guaranteed to have more than 77. Okay, it's already 77, so it's going to be greater than 77. So B is definitely not the answer. Okay. All right, let's go to the next one. When we have 5C, so we have more cases because this gets more complicated, and I'll tell you why. When you can have 2 to the 0, 3 to the, okay, let's say 2 to the I, 3 to the J, and 5 to the K. Okay. Should I just keep C? Yeah, I'll keep K here because I don't want you to confuse with the combined form of all the K's. In other words, C is like or the additional K we can possibly form. So it's like more static number where K is more like a variable number. So I'll keep I, J, K here. In other words, I can have 0 here, 0 there. I can have 0 here, 1 and 0, 1, 1, or like 2, 1, 1, 2. And there will be a lot of possible values that can create the n as long as that n is less than 5300. So this is going to be kind of long, but I'll still list them all, or at least probably first 10. So I'll start with the very easy, both being 0. That's pure fifth, right? Okay. And that's gonna be up to 1, 2, so 25, 125. I believe this is 625. Okay. Okay. We have to stop there, 3125, because once you go 6, it's going to be over 5300. Alright, so let's go down to the when you have 2 to the 1 plus 3 to the 0, and you have 5 to the k. So here I can divide it by 2 just like up there, so I'll get 2650, and obviously we just saw that that's over 3000, so we can use 5 to the 5th power. So we can use 5 to the 1st, 5 to the 2nd, 5 to the 3rd, and 5 to the 4th, and we have to stop there, and then 2 to the 0, and then 3 to the 1st. Then I can divide it by 3 on both sides, so 5300 divided by 3, I get 1766. So 1766.66 and on, and as long as that number, the 5 to the power is less than that, then it's okay. So we'll have 5 to the 1st, 5 to the 2nd, 5 to the 3rd, and I remember 5 to the 4th was 625. Yeah, should be it. 5 to the 4th is 624, and we have to stop there as well. Now let's move on. What if we have 2 to the 2nd? No, 2 to the, oh sure, why not? 2 to the 2nd, and then 3 to the 0, and 5 to the k. That's 4, that's 1. So 4 is divided from 5300, so 300 divided by 4, I get 1325. Okay, I can still go up to 625, so it takes 1, 2, 3, 4. Alright, so another big number, another small number we can form is 2 to the 1st, 3 to the 1st, because that makes it 6, and then 5 to the k. Now if you divide by 6 on both sides, you're gonna get 5300 divided by 6, you get 883. That's still, that takes the 625, so it's gonna be same again. Let's scroll down. What if you have 2 to the 2nd? Okay, we have 6. Oh, we can have 2 to the 3rd. Now we have 8, right? And then 3 to the 0, and then 5 to the k. So we divide it by 8. So 5300 divide by 8. You're gonna get 662.5. Oh, that's very close to that 625. So we still take the 5 to the 4th. Alright. Alright, up to 4. Up to 4. Okay. What else? 2 to the we have 8. Okay, we can have 2 to the 0 and 3 to the 2, and 5 to the k. We have 9. When you divide it by 9, now it's less than 625, so we can take only up to 5 to the 3rd. So here we take up to 3, meaning up to 3rd power. Okay, so we have, let's see, how many cases do we have? 1, 2, 3, 4, 5, 6, 7. Let's do a few more. What if we have 2 to the 2nd? Okay, we have 9. Okay, we can have 2 to the 2nd and 3 to the 1st. I don't think I used that yet. Okay, yes. So 5 to the k. Now I have 12 on the one side. So let's divide it by 12. Okay, I have 441. Okay, remember the 5 to the third is only a 125, so I can have up to 3. What about 2 to, okay, what number can we use? 2 to the third, we use that. 2 to the, yeah, 2 to the third, and then we can have 3 to the second. Oh, well, actually we didn't use 3 to the first yet, so we'll use that. So we have 824. 8 times 3 is 24, so 53 over 24, we get 220. Okay, that still take up to 3. What about 2 to the second and 3 to the third? Okay, 27 times 4, you should get 108. Alright, so 5300 over 108, you're gonna get 49. That's below 125, so we're gonna get only up to 2. And when we have, let's do one more. When we have 2 to the third and 3 to the second, 9 times 8, you get 72. So when you divide it by 72, you're going to get 73. That's still less than 125, so you have up to 2. Now let's add all our exponents, because all these are part of all the fives n, and these are all multiplied in that product. So when you multiply these numbers, you get to add all the exponents. Therefore, it's kind of messy, but let's see how many we have. Alright, so the top is 5. Okay, I'm gonna do this way. So we have 1 through 4, 4, 4, 4, 4. Okay, we have 2 here, so that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The one I see on the top 10 here, excluding the 1, 2, 3, 4, 5. So I need to multiply this by, okay, let me count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 plus 2. Now how many 3's do we have? 1, 2, 3. 4 still has 3, so 1, 2, 3, 4, 5, 6, 7, 8. Now fourth, 1, 2, 3, 4, 5. And then we have 5, right? 1, 5. But that 5 I didn't count, so I would just say 1 plus 2 plus 3 plus 4 plus 5. Because you see up here, the very pure 5K we had, I'm talking about this one. I didn't count that 1, 2, 3, 4, 5, 1, 2, 3, 4, so I have to add them as well. So that's relevant to these parentheses. Alright, so when you add this, 3 times 10, you get 30, 24, 20. Well, obviously, it's already what? 74. And if you add that, that's more than 77. That should be 15. So what does it tell us? Our the C, which is 5 to the C, we saw in the very early. I hope you didn't forget that yet. So if you go up here, we had that 5 to the C here, right? That 5 to the C, that C is more than, or at least we know it's more than 89. We calculated here. Well, more importantly, just it's greater than 77 no matter what. So we proved that C is greater than 77. We proved that B was already greater than 77. And then we also proved that A was 78. So it was pretty close race, but the winner is 67 because he only took the 77 as the exponent. So when you go back to our original question now, we know this was 67, right? That D was 67. So we can at most take 67 to be our M. Now we learned the 78 here, right? On the A. That's okay because when you have 77, you still have 2 on the top, and that's gonna still create our integer. In other words, all these bottom gotta be divided. So the answer must be 77.